Okay, we've been talking about quadratics for some time now, but first let's go over the bell ringer because it's still kind of a quadratic thing in that you have to factor. What's the first thing I should do for this problem? Okay, so I have x squared plus 6x minus 27 equal to 0. And then I heard the debate this group at least was having. It is plus 9 and minus 3. I need two things that add to 6. 9 minus 3 adds to 6. And two things that multiply to negative 27. 9 times negative 3 do go to negative 27. So that is perfect. If we were to graph this, where would our zeros be?
9 and negative 3. Is that right?
The opposite sign. So it's negative 9 and 3. Okay, perfect. So if we were to look back, are there any questions about the bell ringer before I go start quadratic crazy? If we were to look back at our yellow flip book, which is supposed to be useful to us, we talked about this on Friday. It's intercept form. So we like intercept form because you can see the roots. Bless you. We liked intercept form because you can instantly see the roots. We know exactly where those two roots are. It's the opposite sides. Now, what's annoying about intercept form is we don't automatically know that axis of symmetry. We don't automatically know the vertex. There's a little work required to find those things. But one reason some people like intercept form is you can see the roots. Why would we like standard form? What can you see with standard form? You can easily find that axis of symmetry. And what else can you also find easily? I'll give you a hint. Oops, I found it. Yeah, anytime the x is 0, so we can see the axis of symmetry and the y-intercept. My favorite form is standard form because we can see the axis of symmetry and the y-intercept, and because we've spent so long factoring, you can factor and find those roots easier. So, and then today we're talking about one last form, which is named this for a reason. It is called vertex form. It is named this for a reason. Any ideas why vertex form is named? You can see the vertex. But what's super annoying is, you know how with the roots it's opposite signs? With the vertex it's a little bit opposite signs. So let's write vertex form. It's y equals something you've seen before. Ax minus h squared plus k. We've seen something that looked like this before with LTF. We've seen an equation that looked like this before with LTF. We did point slope like this with LTF. The intercept is the point h comma k. I mean, that's the vertex. And we can see it here. But notice that h has the opposite sign, where k does not. Now, why does it have the opposite sign for h and not for k? Because the formula says x minus h squared. It doesn't say minus k. It says plus k. Okay, before we go crazy, let's just start at the beginning again. Does this open up or down?
Open up.
Opens up because a is bigger than 0. And then I'm telling you, I can spot that vertex. Where is my vertex?
Okay, I don't understand how to find this in general.
The vertex?
Yes.
With this form, I'm telling you, you can see it. Uh-huh. Go see her so I can keep talking. Thank you. You're good. Say your words again, Natalia. My ADHD kicked in.
My ADHD.
Yeah.
I don't know.
Okay. In this form, we can spot that. We're told we know the numbers are 2 and 5. Yeah. Now we're just debating: is it positive 2, negative 5, negative 2, negative 5? Both positive. I know it's 2 and 5, but we're debating the signs. Is it negative 2, positive 2, negative 5, positive 5? I need to know that. It's negative 2 because it's x minus h squared So it's going to end up being the opposite sign if it's a plus. So if you had to write it on out, and I guess we could if we needed to,
Now, how did you get
what we really have is x minus a negative 2 squared. Now, how did you know to put it like that? Because the form is x minus h squared. It ends up being that h is the opposite side.
Wait, it's complicated.
You've got to get it together.
But if it's supposed to open up at 1, 2, 5, how is it?
It can still open up at negative 2, 5. Negative 2, 1, 2, 3, 4, 5.
It's going to be tiny.
Oh, or have I done that wrong? Is my vertex at negative 2, 5? Where is my vertex?
5, negative 2.
No, 5, 2. Negative 5, 2.
I know the x coordinate is 2. I know the y coordinate is a 5. I'm debating the signs. The x coordinate ends up being the opposite sign. So it said a plus 2 here, so it ends up being a negative 2. The y coordinate stays the same. It should be negative 2, negative 5. So it is going to work on our graph because it's negative 2, negative 5. Let's say this again. You like y equals mx plus b because it's got the plus sign. What's annoying about this formula is it looks like the one we were talking about yesterday or Friday, where the roots ended up being the opposite signs because of the minus. Weren't the roots the opposite sign because of the minuses here? So if we saw this, we knew the root was really at negative 1 and positive 3. Yes? In the same way, in vertex form, the x coordinate ends up being the opposite sign. So it said plus 2, it's going to be a minus 2. Are we going to what?
Have to use all 3 of these forms? Or do you just have to pick one you like?
You're given, it's just like with a line. You're given what you're given and you got to deal with it. Okay, now we're making life way too complicated. We are. We genuinely are. It's easy to spot. It ends up being the opposite sign with the x and the same sign with the y. So for us, it was a positive 2, so my x is negative 2. It was a minus 5. It doesn't change. It stays a minus 5. This form is the easiest of them all because we can spot the vertex. And once we know that vertex, we also know that axis of symmetry. Because I know the vertex is the only point that hits that axis of symmetry. So I know my axis of symmetry is at negative 2. I know that. If I wanted to put x equals negative 2, that'd be even better. Now you can make your life complicated, and you can start doing what we were doing last week, where you plug in 0 to figure out where the roots are. You can plug in whatever and figure out other points. Or you can remember our trick. Since our a is 1, and we know that bottom point, we can go over 1, up 1. Over 2, up 4. Over 3, up 9. And again, it's still symmetric. So once I know that vertex and that axis of symmetry, if my a is 1, that bad boy is really easy to graph. So all we're really doing today is looking at this weird form. It's called vertex form. It shows you where the vertex is. But it ends up being the opposite sign of what you think for the x coordinate. Because in the form, it's x minus h. That's why the x coordinate ends up being the opposite sign. The k coordinate's not, but the x coordinate is. Okay, so then let's look at number 2. Does it open, or example 6 actually, does it open up or open down? How do you know it opens down? Because it's got that negative for the a. And then this is the hardest part, but I swear once you got this part, you got the whole shebang. Where is my vertex? Negative 2, 3. It's the opposite sign for the x, so it's a negative 2. It's the same sign for the y, so it's a positive 3. Are there any questions about how I spotted that vertex?
What about that negative sign being in that positive?
That's just making me turn down, and that's what makes me the frowny face.
I know that wouldn't like.
No, that's all that's telling you is the a is negative 1, whereas on here, the above example, a was positive 1. That's just the a. Doesn't matter what sign it is. Not going to change our vertex. Okay, so I go to. I lied to you, and I hate it when I lied. I knew when she asked that was a darn good question. I almost cussed on my YouTube video. Darn it, Natalia.
Am I right?
I love it when you're smart.
Not smart.
I don't know if you are right. I'm questioning my own life. No, I'm right. Okay, good. I had to look at the key and everything, Natalia. Golly. Got me questioning my math on a Monday morning. No, what I above statement was right. That's just the A. Okay, my vertex is at negative 2, 3. 1, 2, 3. I've got my vertex. What is my axis of symmetry? Is it supposed to open up or open down?
Down.
And then I go over 1, down 1. Over 2, down 4. Over 3, down 9. Now, if Natalia wants to make her life complicated and she's questioning my sanity, could she end up factoring this all out to then figure out the 2 roots and make sure and check me? She could. Or maybe she doubts me on the y-intercept. So she plugs in a 0 and she figures out it really should hit at negative 1. She is allowed to question my sanity. We can still do all the other steps we were doing the other days. All I'm saying is that if I were to go back up to the top, if I were to make a note to myself about why I love vertex form, you can see the vertex and the axis of symmetry. And to be honest, if you can see that vertex and that axis of symmetry, and as long as A is 1, that bad boy is super easy to graph. Okay, and then just humor me because I'm starting to question everyone's sanity, including my own. What is the vertex of this parabola that I just made up?
Yes.
Okay, then I'm not questioning my sanity anymore.
I got that right.
Yeah, it's the opposite sign for the x, same sign for the y. Yes.
Thank you.
Okay. I don't know what she handed me, but it looked nice. John David, give everybody one of these. Allison, come press stop on my recording, please. You're smart. You'll figure it out. John David, can I have one of those too?